So we're going to look at, we're doing Chapter 6, Practice B, and we're going to do problem 9. So we're going to write our given and find. So it says a bullet of mass 50 grams. So the mass of the bullet, again, if I have two objects, I need to differentiate between the objects. So I'm going to call them A and B. So I'm going to call the bullet A, and it's 50 grams. And one of the things I want to do right off is that's the bullet. I know I need to convert that to my basic unit. So right away I'm going to convert the grams to kilograms. Okay. It strikes a wooden block of 5 kilograms. So I'm going to call the block B. So this is the block, and this is the bullet. And becomes embedded in the block. So if I want to picture this, the block then flies off, the block and bullet then flies off at 10 meters per second. So they're together. So it doesn't say in this problem, but the velocity of the block is 0. And if I want to conceptualize this, the bullet is going to have initial velocity, and it's going to strike the block that's initially at rest. And then after, the block is going to be embedded in, the bullet's going to be embedded in the block, and they're going to move off together with one velocity. Okay? So the question says, what was the original velocity of the bullet? So I want to find VA. And what I didn't write down was that the two of them are together, so V prime, which is the velocity of the bullet inside the block, is going to be 10 meters per second. So with conservation of momentum, we know that the total, and this is just in layman's terms, the total momentum before is equal to the total momentum after. And the total momentum before, again, I don't have to write all these intermediate steps, but I'm just going to explain, is going to be the momentum of A plus the momentum of B is equal to the momentum of A after and the momentum of B after. And we know the momentum of A is going to be MAVA, and this is going to be MBVB. I'm just going to derive the equation that we're going to use for this, even though I already did that. So this is going to be MAV prime plus MBV prime. Because these both have the same velocity, now I can simplify that second half of the equation and just say V prime. But most of the time in a problem like this, you're just going to know that this is what we're going to use to solve the problem. So what do I have, and I have all my masses, and I have this is 0, so I want to find VA. So what I'm going to do is I'm going to rearrange the equation to solve for the unknown in terms of the known. So now we're just doing some basic algebra. Am I going to plug my numbers in now? No, because if I do that, I'll make a mistake. So what I'll do first is, because I want to solve for VA, I want this to be in the numerator all by itself, right? So I'm going to have MAVA is equal to MA plus MB times V prime. And because this is addition, I'm going to subtract it from both sides, so it's going to be minus MBVB. Now I'll divide both sides by MA, so VA is MA plus MB times V prime minus MBVB all over MA. Now, before I start substituting, I know that the initial velocity here is 0, so I'll just get rid of that. And now I'll substitute in my values. So it's going to be 0.05 kilograms plus 5 kilograms times 10 meters per second divided by the mass of the bullet, which was 0.05. And when I do this on my calculator, VA comes out to be 1010 meters per second, and then in correct significant figures, I would just say 1 times 10 to the 3, which is what you guys have in parentheses on your problem sheet. So again, we just need to keep in mind the total momentum before is equal to the total momentum after. And when we write stuff down and we chunk, we read, we write, we can keep track of what's what. And the concepts are going to be the same throughout. And that's it.